Hello everybody, welcome to day 6 of Advent of Code 2023. I'm well rested, so hopefully today's problem will be less confusing to me than yesterday's. So, day 6 is called Wait For It. So we will be working some ferries, some boats, boat racing. There's a lot of backstory here, but the meat he's here, so our goal is to win the race, I guess. Then we have a sheet of paper, which is a power puzzle input, and there it lists some times allowed for each race and the best distance ever recorded for that race. To guarantee we win the grand prize, we need to make sure we go farther in each race than the current record holder. So we need to go farther, not the same distance. The boats are actually toy boats, which have a big button on top. Holding down the button charges the boat, and releasing allows the boat to move. The boats move faster if their button was held longer, but time spent holding the button counts against the total time of the race. We can only hold the button at the start of the race, and boats don't move out until the button is released. So here's an input. So this time it's kind of a very simple input as compared to the previous days, I guess. Just two lines of input, time and race. So we have time. So we have time 7 milliseconds and distance 9 milliseconds and so on. And our boat is starting at a speed of 0 millimeters per millisecond. And for each whole millisecond we spend at the beginning holding down the button, the boat's speed increases by 1 millimeter per millisecond. Because the first race lasts 7 milliseconds, we only have a few options. So we don't hold the button at all, but then the boat doesn't move at all. If we hold it for 1 millisecond, it will have a speed of 1 millimeter per millisecond, and it will travel that speed for 6 milliseconds because we held it for 1 millisecond, and we reach the total distance of 6 millimeters. Similarly for the other distances. So it means that the longer we hold the button, the longer we get, the greater distance we can reach because we have greater speed. But if we hold it for too long, we will not have enough time to actually travel that fast, travel that long with that great speed. So it's kind of you give and take. You have to pick the right balance between the speed that we set to the boat and the time it travels. So the distance increases and then decreases again. So because the current race record is 7 millimeters, there is 4 different ways you can win by holding for 2 milliseconds, 3, 4, and 5, and so on. So we will be calculating the ways to win, and we need to determine the number of ways we can beat the record in each race and then multiply those values together to get the resulting number. So this seems kind of reasonable. So let's see if we can solve this problem quite easily. So I need to copy the sample input first so we know that our solution works, of course. And what I will do, I will read input, read all lines, and then var line, so times equals line input 0 substring. So what is the time? So we need to split it, remove entries, and trim entries as usual. And then we select int parse to get the actual values, and we do the same thing for the races. So records distance. So that's this one. So now we need to figure out how to properly calculate. So we will go for, no, that's not it. We will go for each race. And then we will be calculating the best time. So the simple way to do this would be to go through each of the possibilities and just check if we beat the record. So because the values in the input are very small, it's probably the easiest way to do this. So let's do for total time equals times a race records race. And now we just do very simple ways to win equals 0, and we will do if total, let's rename this to time so it's nicer. So if time times, so this is the time we hold the button, and this is the distance that the boat will travel. If it's greater than the record, then we just ways to win plus plus. Very simple, but should be enough. So total equals 1, and we will be multiplying this with ways to win, and then console write line total. If I'm not mistaken, this could be enough in this case. So ways to win the first one. Oh, I made some mistake here. So the record is 7. Oh, I'm parsing incorrectly. I am parsing the same line twice. Copy paste errors are the worst. So ways to win the first one. Still there is something wrong. So 9:40 time. Of course. Yes, also simple mistake here, where you should be going by total time. So we go from 0 time to total time. Now we should be okay. So the first one is 4, and we have 8, and we have 9, which is correct. So let's see if the results work. So it's 288. So now we'll try the big input, which is still reasonably small. I don't see a problem here. So this should be the result. And that is correct. So we have first part of the problem done. Now let's go to the second one. So as the race is about to start, we realized that the piece of paper had very bad kerning, so there's just really one race. We ignore the spaces between numbers on each line. So now instead of this, we have this. Well, it's definitely different. All right, so the number will be now much bigger than before. So we may need to avoid calculating this whole thing and figure out some simpler solution. So let me copy this here. Let me copy this here. And now let's figure out what we can do. So we need we substring the time, and we replace spaces by empty string, and then we parse the int now. So what I want to do here, get rid of all the spaces and parse that time. So I will replace empty string and parse the time, and should get the race time and record. Replace, get rid of this. So we have now just one single race. And we're still calculating the ways we can win this, right? Right. So now things get a little bit more interesting, because we will be going through much bigger space. But for this simple sample input, it should be still reasonably fast. So this is correct solution, but I think it's not applicable to the big input here, because it will, well, we'll see what happens. Yeah, it's overflowing. So we would need to replace this with longs, which could be enough. Yeah, so it did give us a result here, but I think the proper way to solve this would be a different one. Okay, so we have the correct solution, so that's good. But what I am thinking is that because the total time is growing and then decreasing the same rate, it should be calculated. It should be possible to calculate this. So because the time we are looking for, the x time, is we need to reach this goal. It's a like quadratic equation. So what we could do is to write yes, and then did this, yes. very useful Copilot suggestions. So this is what I would like. I would want to calculate this quadratic equation, calculate the value, and then it should be enough, hopefully. But we want to reach at least record +1. So I would say this is the proper way to do this. So I would say you would calculate the determinant is b squared minus 4ab. Yes, that's correct. And now our x1 equals total time minus b, which is total time. Oh, Copilot is very useful. You can see this helps immensely when you don't really remember your basic mathematical skills anymore. So you get the 2x and x1, x2, and I would say I would take the time as math min of x1, x2. So I get the time where it starts working. It could be a double, it could be a fractional number. So I would do math ceiling of that value. And then make it an integer or long. Now the ways to win would be equal to total time minus time. So we start winning at time of time and stop winning at the last point when we win is total time minus time. So it's gonna be minus time plus 1, because we want to include even that edge, the last winning time, and that should be the same result, hopefully. Yes. All right. So now, yeah, this is probably much better solution, because it's in a constant time instead of linear time with the total time value. So this is much more efficient. So yeah, we found actually two ways to solve this problem, and that's pretty nice. So I hope you enjoyed this edition of Advent of Code for day 6. And I will be back tomorrow for day 7, and also back again today with AI versus this problem. I am guessing this problem should be quite easy for ChatGPT to solve. So we will see, and you can tune in for that next video to see if it's actually the case or not. So thank you again for joining. Have a great day and keep coding.